So we're going to continue our unit talking about different types of lines. We've talked about their equations. Let's talk about four ways lines can be described. We can have intersecting, perpendicular, parallel, or skew. Now, these are all different ways that we can talk about it. We know intersecting means two lines that share one point. Okay, that's what we mean by intersecting. They actually have a point in common. Okay, so a line with another line are intersecting lines. Perpendicular is a special form of intersecting. This is two lines that intersect to form a right angle. Okay, so that's a line here and maybe a line there. Now, when they intersect, we end up getting a right angle. That's what we mean by perpendicular. Parallel lines are two lines in the same plane that never intersect. And we've seen examples of that, a line and another line. But here's the catch, it's in the same plane. If we have two lines not in the same plane, they could still not intersect. And that's what we call skew lines. So skew lines are two lines in separate planes that never intersect. I tell you what, let's change camera angles and I'll show you an example of that. So if I change my camera, so what we're looking at is we have a line here, okay, that's in this plane. So it's got its own plane here, okay, going out this way and all this way, that's its plane. And we can bring in another line right at you, okay? So the line coming right at you is not going to touch this line up here. This line's not going to touch this line, but they're not in the same plane. Now, if I turn them this way, now they're parallel because there's a plane that they share that can be drawn in between the two. But if I rotate that in any direction, now it's a skew line. Now they're skew lines. Okay, so that's what we mean by skew and being in two separate planes. Let's change back to our note camera and see what else has got going on here. So determine if these lines are parallel, perpendicular, or skew based on this drawing here. So go ahead and do that. Remember, you can also connect two points that don't have a line already drawn in there. And the lines keep going on. We're not just talking about where they stop. So give that a shot. Okay, so taking a look at these examples. AB is here. CD is down here. Notice they're in the same plane. They share the side of the box there. So that means that they are parallel. EF and DG. Well, EF, I'll draw EF here, and DG is going there. They're in two separate planes, okay? EF is in a plane here or up there. DG is here. So those are going to make those two lines skew. AF cuts across this way, and EF, well, right there, that should be a dead giveaway. They both share point F. That should automatically tell me that they're intersecting. And then CG is going to be here, and AH, which is going to be at a weird angle. It's going to come here and go out that way. So they're obviously not ever going to touch each other either. So that makes them skew. So what's that mean about their slopes? Well, parallel lines, since they never touch and are in the same plane, I could calculate this slope, rise 2 over 1, and this one, rise 2 over 1. They have the same slope, or equal slopes. Okay, so parallel lines always have equal slopes, which makes it really easy to determine what the slopes of if lines are parallel or not, just from the equations. Like I can look at this equation and go, okay, let me get it. That one's in y equals form, so this one has a slope of -1. If I put this into y equals form, -1x minus 3, they also have a slope of -1. Notice they have two different y-intercepts, so they're not the same line. Check out the next two, see what you can do. Are they going to be parallel or not? Okay, so this one, we put into y equals 5y equals -3x plus 15. So y equals -3/5 x plus 3. So a slope of -3/5. And here, 3y equals -5x plus 15. So y equals -5/3 x plus 5. Slope is -5/3, not parallel. Not the same number. Okay? Taking a look at this one, this has a slope of 3, a slope of 3, and they have different y-intercepts, so they are parallel. Okay? Always simplify your slopes. So that brings us to our last question, perpendicular lines. Two lines are perpendicular, they have slopes that are opposite reciprocals. Now, what does that mean? Opposite means positive versus negative, okay? Reciprocal is a flipped fraction, okay? So what we're looking for is if my slope is negative, I want its opposite reciprocal to be positive. If it's positive, I want the opposite reciprocal to be negative. And I want the reciprocal part to be flipped, okay? So when I look at this one, I go, okay, let's set it up. Y equals -x plus 5. Y equals -x minus 10. The slope of the first line is -1. Slope of the second line is -1. They're not opposites. They are reciprocals, because remember, the reciprocal of 1 is 1. So, but these two are actually parallel. That should already tell me I can't be parallel and perpendicular. So not perpendicular. Try the next two, see what you get. So if we calculate this one, let's say the top line, it's going to be 2y equals -3x plus 5. So y is -3/2 x plus 5/2. 3y equals 2x plus 5. Y equals 2/3 x plus 5/3. Slope is -3/2. Slope is 2/3. Opposites, reciprocals, so perpendicular. And on the last one, let's see, -8y equals -3x plus 11. That's going to give me y equals 3/8 x minus 1/2. So 3/8 is my slope. And -6y equals -3x plus 10. Y equals 1/2 x minus 5/3. Not even close, not even pretending to be close. So this is not perpendicular. Also not parallel, they're just intersecting lines. Okay? Now we're going to use this idea of parallels and perpendiculars to talk about other things with lines and doing equations of lines tomorrow. So try that out, and we'll see you tomorrow.